So today I want to look at finding the square roots of values, in particular finding the exact square roots of values rather than finding the decimal approximation. But before we do that, I want to review what a square root is. So this is our square root sign. Let's say I put the value of x underneath the square root sign. The symbol itself is called a radical sign, and any value underneath the radical sign is called a radicand. And the question we're actually asking when we have a square root is what number squared equals the radicand? For example, if we had the square root of 16, well, our square root would be 4, both positive and negative, because 4 times 4 equals 16 and negative 4 times negative 4 equals 16. So we have two possible answers for that square root. So I want to look at finding the exact square root. And to do that, we're going to have to factor our square roots. And I first want to compare exact versus approximate answers for square roots. So let's take the example of the square root of 8. And if I plug that into my calculator, I'll get positive and negative 2.824, and the value continues on after that. So at some point, I'm going to have to round my value. Once I round this decimal, it becomes an approximation. So we no longer have an exact answer. To find our exact answer, we need to identify our perfect squares. So here's a list of the first 12 perfect squares, and I want to start by, to find the exact square root of 8, I want to start by factoring the square root of 8 and try to get one of these perfect squares as my factor of the square root of 8. So I can factor the square root of 8 into the square root of 4 times the square root of 2, and I notice that, well, I have the square root of 4 right here. So I know my square root of 4 is positive and negative 2. My value for 2, my square root of 2, isn't a perfect square, it's a prime number. I can't factor it, and factoring won't help me. So I'm going to keep it the square root of 2. So my answer for this, when I find the exact square root of 8, is going to be positive and negative 2 times the square root of 2. So let's do another example, and for this example, I want to find the exact square root of 20. Now 20 again isn't a perfect square. So we're going to factor 20, and I want to try and get one of these perfect squares as a factor of 20. So the most obvious factors of 20 are going to be 4 and 5. So I have the square root of 4 times the square root of 5. My square root of 5 is a prime number, so there's nothing I could do with that 5. So I'm going to keep it as the square root of 5. Square root of 4 is 2, so I have positive and negative 2 times the square root of 5. So this is going to be my square root of, my exact square root of 20, positive and negative 2 times the square root of 5. So let's use another set of factors with the square root of 20, and this time I want to use the square root of 2 times the square root of 10. So we're not identifying a perfect square right off the bat as we did here. We identified square root of 4 as a perfect square. We don't have a perfect square here, but we can still get a correct answer. So there's nothing I could do with that square root of 2, but I can factor the square root of 10 into the square root of 2 times the square root of 5. And now remember, our goal is to get a perfect square when we factor our square root of 20, when we factor our radicand. So I notice, well, I can combine square root of 2 times square root of 2, and I'm going to get the square root of 4. So I'm going to multiply square root of 2 times square root of 2, and I get back the square root of 4. All right, I have the square root of 5 left over, so I have square root of 4 times square root of 5, and I have at this step what we had here, the first step of our original problem. So again, square root of 4 gives me positive and negative 2 times the square root of 5. So let's find the exact square root of 4 times the square root of 80. And to do this, I'm going to start by factoring 80 into the square root of 16 times the square root of 5. Now 16 is the largest perfect square that'll go into 80. So my square root of 16 will give me positive and negative 4. So at this step, I have 4 outside the radical, I have positive and negative 4, and I have the square root of 5. So I can put all this back together. So I have positive and negative 4, and I'm multiplying these three terms times 4 times the square root of 5. And I'll get positive and negative 16 times the square root of 5. So I'm going to do the same example using some different factors. So I'm going to factor 80 into the square root of 8 times the square root of 10. And I notice I don't have any perfect squares here, so I'm going to continue factoring. And I could factor 8 into square root of 4 times the square root of 2. And 10 I'm going to factor into the square root of 2 times the square root of 5. So at this step, I want to look and see what I have. Well, I notice I have 4 outside of the radical, so I'm going to rewrite that 4 down below. I have the square root of 4 here, and I know the square root of 4 is going to give me a positive and negative 2. So I'm just going to bring that positive and negative sign out in front of my 4. I also have square root of 2 times square root of 2. Well, square root of 2 will give me the square root of 4. And I have the square root of 5 here. So I'm just going to bring down that square root of 5. Okay. Now, the square root of 4 will again give me positive and negative 2. So I'll rewrite next step what I have. So I'll bring down the 4, bring down the 2. Square root of 4 gives me positive and negative 2. Again, my positive and negative signs are out in front of my expression times the square root of 5, and I'm multiplying all these terms. So at the last step, I have positive and negative 4 times 2 gives me positive and negative 16 times the square root of 5. So let's find the exact square root of an example with a fraction. So if I have the square root of a fraction, I could break it up into the square root of the numerator over the square root of the denominator. Now, in my numerator, I have the square root of 3. Factoring it into the square root of 1, square root of 3 isn't going to help me. So I'm just going to keep it as the square root of 3. Again, 3 is not a perfect square, so I'm just going to leave it as the square root of 3 in the numerator. The denominator, my square root of 16, is one of my perfect squares. So that's going to give me positive and negative 4 in the denominator. So the square root of 3 over 16 simplifies to positive and negative square root of 3 over 4. So I want to do another more complex example. I'm going to work with the square root of 81 over 5, and I want to find the exact square root of that. So the same as the previous example, I'm going to factor and break it up into the square root of the numerator over the square root of the denominator. And I notice that in my numerator I have a square root of 81. Well, that's my perfect square. So that's going to give me positive and negative 9 in the numerator. But 5 in the denominator isn't a perfect square, so I have the square root of 5 in the denominator. Now what do I have to do? Whenever I have a square root in the denominator, we can't leave a square root in the denominator, so we have to do what's called rationalizing the denominator. And when I rationalize by the denominator, I multiply the numerator and denominator by whatever the square root is. In this case, the square root of 5. So let's start by multiplying both the numerator and denominator by the square root of 5. So 9 times square root of 5 in my numerator will leave me with 9 square roots of 5. Square root of 5 times square root of 5 will give me the square root of 25. And square root of 25 is my perfect square. So that gives me positive and negative 5 in the denominator and 9 square roots of 5 in the numerator. So by rationalizing the denominator, I was able to get rid of the square root in the denominator. I got a perfect square in the denominator, and it left me with 5 in the denominator, and my entire fraction simplified to positive and negative 9 times the square root of 5 over 5. So I'll do one more example that involves rationalizing the denominator. So I have 10 over 3 times the square root of 2. So our first step is going to be to rationalize the denominator with that square root of 2 in the denominator. So to rationalize, I'm going to multiply both the numerator and the denominator by that square root of 2. Okay. So 10 square root of 2, I can't actually multiply them, so I'm just going to have 10 times the square root of 2. And in the denominator, I'm going to have 3 times square root of 2 times square root of 2 gives me the square root of 4. And my next step, I'm going to keep my numerator, 10 square roots of 2. In my denominator, square root of 4 gives me positive and negative 2 times 3. So again, multiplying my denominator, 3 and 2, I get 10 square roots of 2 over 6, and that's all positive and negative. So I got rid of the radical in the denominator, but now let's look at the terms that are outside of the radical. I have 10 and 6. So I have a common factor of 2 for both 10 and 6. So I'm going to divide both 10 and 6 by 2, and I get 5 and 3. So this fraction is going to simplify to 5 times the square root of 2 over 3, and that's all positive and negative. So let's do a few examples. So let's start with 3 square roots of 60 and find the exact square root of that. So take a second, pause the video, and find the exact square root of 3 times the square root of 60. So our first step, I'm going to factor the square root of 60 into the square root of 4 times the square root of 15. Square root of 4 gives me positive and negative 2. Outside of my radical, I have that 3. So I'm going to multiply positive and negative 2 times 3 times the square root of 15. And I'll get positive and negative 6 times the square root of 15. Now you may have used different factors for this, so I'm going to factor this into the square root of 6 times the square root of 10. I don't have perfect squares here, so I'm going to continue factoring 6 and 10. And 6 we could factor into square root of 3 times square root of 2. 10 I could factor into the square root of 2 times square root of 5. Now I want to put together these square roots and see what perfect squares I can make. Well, I notice I have square root of 2 times square root of 2. So that's going to give me the square root of 4. I have 3 outside the radical. So I'm going to have 3 times the square root of 4. And I have square root of 3 times square root of 5. So I'm going to multiply by the square root of 3 times the square root of 5. The square root of 4 gives me positive and negative 2 times 3. And I'm going to multiply square root of 3 times the square root of 5, and I'm going to get the square root of 15. Now I can multiply 3 times positive and negative 2, and I get positive and negative 6 times the square root of 15. And for this example, I pulled that positive and negative in front of the entire example. And our simplified expression is positive and negative 6 times the square root of 15, same thing that we had here. So let's do an example where we have to rationalize the denominator. So let's do 12 divided by the square root of 2 and find the exact square root of this. So take a second, guys, pause the video and simplify 12 over the square root of 2 by rationalizing the denominator. All right, so our first step is when we rationalize, we're going to multiply by the square root of 2 over the square root of 2. So whatever our square root is in the denominator, we're going to multiply it by the numerator and denominator using that square root. So I'll get 12 times the square root of 2 in the numerator. Square root of 2 times the square root of 2 gives me the square root of 4 in the denominator. And the square root of 4 gives me positive and negative 2 in the denominator. Again, I'm just always bringing these positive and negatives out in front of the fraction. And my numerator stays 12 times the square root of 2. Now, I have 12 in the numerator, 2 in the denominator, so I can simplify, divide 12 by 2, and I'm left with positive and negative 6 times the square root of 2. All right, so this positive and negative 6 times the square root of 2 is our 12 divided by the square root of 2 simplified.